This is Mr. Word, and I'm going to do a video on some section B, set B problems from the arcs, chords, and central angles section 10.3 on the circles chapter. So let's start talking about this. We've got this problem. This is problem 12. It's cut off by, of course, the feature here. There, we got it. So we know that AD is a diameter of circle E. We know that measure of arc AB here is 9x plus 30. We know that measure of arc CD is 54 minus x. And we know that C is the midpoint of arc BD. Okay, so you should pause the video and see if you can figure out what the measure of angle AEC is. The measure of AEC can figure out with some simple algebra and analysis of what the information says. So assuming you paused and you've come back, I'm going to walk through fairly quickly how to deal with this. So first of all, we can label this arc with that, and then we're going to label arc CD with that, but we can also label arc BC with that as well, because those are both going to be congruent since C is a midpoint of the arc. So let's use that information. And we also know that AD is a diameter, so all of this adds up to 180. So we get 180 is going to equal the measure of AB, which is 9x plus 30, plus 2 times the measure of CD, because CD is only half of BC. So 2 times 54 minus x. And then we can just do the algebra to solve that. We're going to solve for x, and once we know what x is, we can figure out what 9x plus 30 is, because and what 54 minus x is. Add those together. That will get you the measure of angle AEC. So let's do that really quickly. So 9x plus 30, we'll deal with the, let's distribute the 2 times 54 minus x. So that becomes, let me copy this. Okay, so that is, okay, 2 plus 2 times 54 is going to be 108. So 108. And then minus 2x. And so minus 2x I can deal with here. And that, take my 2x away from 9x, and I get 7x. And I combine 30 and 108. I get 138. And then I need to subtract that from 180. So 180 minus 138. Take the 138 away from this side since I've subtracted it from both sides. And that's going to give me 42. So 7x equals 42. Both sides are 7 times too big. So I make them 7 times smaller, divide both sides by 7, and oops, wow. We're moving around fast, more than I wanted to. All right, I'm going to pause the video and get to where I want to be. Like I said, if I divide both sides by 7, 7x equals 42 becomes x equals 6. So now I need to add the expression for arc AB and the expression for arc CD. The expression for arc CD is the same as the expression that would be for arc BC, and we need that and the expression for AB to combine. So we just need to add 9x plus 30 plus 54 minus x. And we know what x is. X is 6. So we'll just replace x with 6 everywhere it shows up and do the math. So 9 times 6 is 54. 54 plus 30 is 84. And then 84 plus 54 is going to be 138. And then we'll subtract 6, and 138 minus 6 is going to be 132 degrees. Now we need to find the length of a chord that cuts off an arc that measures 60 in a circle of radius 12. All right, well, it would be useful to draw that situation. So I'm going to go ahead and drag this up a little bit so I have a space to draw. And when you draw it, you want to capture these basic ideas of what's happening here. So I'm going to use black for this one. So I'm going to make a circle. That was terrible. Try that again. See if that works this time. Wow, super laggy. Okay, so we have an arc that cuts off 60 degrees. Okay, so I'll draw a radius, and I'm going to roughly draw the arc there. Okay, and we're trying to figure out the length of that chord. Okay, well, if that's 60 degrees, then, all right, let's back up. So the arc is 60 degrees, so the measure of the central angle is 60 degrees. Think about what that means for the overall triangle that's been created here by the chord. And I'm hoping you'll pause this and you'll figure this out. Well, and you've come back from pausing it. You really did pause it. Please do that. Figure this out. You can do this because this is 60 degrees at the central angle. And it's an isosceles triangle with an apex angle of 60 degrees. And if it's isosceles, these two are what's left over of 180. So that's 120 degrees, but they're the same. So they're both 60. So this is actually an equiangular triangle, which means it's equilateral, which means the radius and the base are the same. So the length of the chord is 12. It's the same as the radius. Let's try a couple more here. See what I have time to do. I realize this is a long video, but you're welcome to skip around as needed. Okay, now number 14. AB is a chord of circle E, and C is a midpoint of arc AB. We want to prove that the line EC is the perpendicular bisector to the chord AB. So once again, you want to draw the circle. Okay, I've drawn an amazing circle. You want to plot A and B, and the midpoint of A and B, the arc AB. So this is A. Right, you don't need to watch me write all that, so I'm going to pause. All right, I've drawn the stuff that is in here. So I'm going to ask you to consider how you could use this to prove that EC is a perpendicular bisector to the chord AB. Okay, hopefully you've paused and you've worked this out. So I'm going to go ahead and draw radii, which we know are going to be congruent. So AE and BE are going to be congruent. And now what I've done is so we know that this angle, this is bisecting the arc. So this is the midpoint of this arc, which is being swept up by this central angle. And now we know that this central angle and this central angle have to be congruent because they intersect congruent arcs. So now I've got two angles that are this. I've got the angles are congruent. I've got the radii are congruent, and I've got this segment here that leads to the intersection with the chord. That segment is itself. So I've got side angle side, so I can prove these two triangles are congruent, and that means that I can prove that. I guess I need to come up with another point. We'll call it F, and that's the intersection right there, right here. That's the intersection. Okay, that is F. And so AF and BF are going to be congruent. I'll just mark it with a different color. So that's congruent to that. And so we have bisected it. And if we bisect a chord from a segment from the center of the circle, then we also perpendicularly bisect it. We know that we can also prove, of course, that we could prove some things about triangle. Here we could work out that AC and BC are congruent if we wanted to, and then we would actually, let's do that. Let me use a different color for that. So I think that might be even more powerful proof for this. So we know that that and that are going to be congruent by kappa kata ka, because AEC and BEC are also going to be congruent triangles because of side, angle, side as well. So I didn't need to necessarily prove the bisecting, but it helps. Actually, I think I probably did need to prove that bisecting. And I can also say that C is equidistant to A and B, and E is equidistant to A and B because of radii. So I've got 2 points that are equidistant to the endpoints of that segment, and therefore EC determines the perpendicular bisector of chord AB. Number 15, we are given circle Q, and we have a midpoint, and B is the midpoint of arc AC. We need to prove that angle A is congruent to angle C. So angle A is congruent to angle C. So we know B is a midpoint to the arcs, which means that this arc is congruent. So that means that this arc here, AB, is congruent to arc BC. So think about what you could do to prove that angle A and angle C are congruent. That's what we want to figure out. All right, hopefully you have taken time to do that. I'm going to, and you've come back, I'm going to note that we have some congruent stuff we can work with. QA is congruent to QC because they're radii. And because those arcs are congruent, we can say that chord BC and chord BA are congruent. And you might be tempted to use this angle, but don't use the angle. We can just use QB is congruent to itself. Why is it doing this? Okay, thank you. All right, so QB is itself. That should have been in black, but I'll do that here. I'll probably stop this video after this one because I think it may be exceeding capacity. At any rate, now I've got side, side, side for those triangles, so it's easy to prove by kappa kata ka that angle C and angle A are congruent. I'm going to stop, and we'll go from here.